Okay, the first definition we're going to do for cosine comes from the triangle. So in this definition, thinking about it as a function, I'm going to draw a little function machine here, a function where what we input is an angle, and we do the little cosine to our angle, and what we get out is a ratio, and that ratio is the side adjacent to theta over the hypotenuse. So that's our function for cosine. And truly we can define cosine of theta as I just said, the side adjacent to theta over the hypotenuse of the triangle. While we're talking about cosine as a function, we're just going to talk a little bit about its domain and range. Domain is the possible inputs of the function. So in this case, it's the possible values of the angle theta. Since we're working in a right triangle and theta is not the right angle, it must be one of the two acute angles in the triangle. Therefore, theta must be bigger than 0 degrees, but less than 90 degrees. And I'm going to use a theta there, not an x, because I don't want to throw us off, you'll see on the next video. So if we're talking about degrees, theta must be between 0 degrees and 90 degrees. If we were working in radians, then theta would be between 0 and pi over 2. So that is the domain, because it must be one of the acute angles in the right triangle. And as you can see here, it's strictly greater than 0. There's no equal to. It cannot equal 0 or 90. The range is the possible outputs. So it's the possible values of the ratio here adjacent over hypotenuse. Since we know from our knowledge of right triangles that the side adjacent to theta is always less than the hypotenuse, we have a fraction where the denominator will always be bigger than the numerator. So this fraction will always be less than 1. And of course, it needs to be positive because all the sides of the triangle are all positive numbers. So our cosine of theta is going to be bigger than 0, but less than 1. Again, strictly greater than, strictly less than. It can't equal either of those two numbers.